All right, so we continue on this radical section part. All right. Who is Senjie? I don't know who is Senjie. Can you change your name, Senjie? Who's your Senjie's iPad? Change your real name. Is Brenda? Is you? Can you change your name? All right, so let's move on here. So like this kind of is addition radical, and we also do the subtract one, a bit subtract one, also like combine like terms. And a little bit further is talking about x times y, right? This one can be changed into x times y, like this, right? Of course, this one can be also split. When we do the simplify process, we often make it split, right? Something like this one. Now say x. Actually, this one is split. Is 16 times x became x 4 square root x, right? This split process. So right now we also say when they divide, so this one can be combined inside as well, right? That would be the same thing as what we try to see. So this one can be changed like this, and also can be changed like this. The thing is x and y both actually need to be greater than 0, right? In this condition, if they're both negative number, something like in this case, both is negative number, after divide, they became positive. So if you go to this direction, you need to make sure x greater than 0, y greater than equal 0, all right? So when you do the backward, this case, you need to make sure that inside x, y, both need to be greater than 0 before you split, all right? Okay, so when we do the times, that will be easy because of everything they are so close to each other, right? So close as can be well done. But if they do when they split this one, when similar, just what are we talking here? X and Y, both of them need to be both positive or both, when they both negative, you cannot split it like this. You need to make sure this one became absolute, right? So this is the condition. Only when both x and y both greater than 0 or equal 0, we can do this one. Yep, thank you. Thank you, someone help me add here. All right, so let's see some examples. When we do this one. Yep. So let's see something here. Say, wait a minute, sorry for this one. So when we say square root 5, like this case, so we're not one, and we see this have two kinds of term of them. How we do this one? So this is exactly the same as what we earlier doing. We use the distribution process, like A times B plus C, right? So this one equal AB plus AC, right? Same. So here I can say, after you time this, you can distribute inside, right? So you can got, so this part, this is the step of using this kinds of distribution process. Hello, Brian. So they begin, so after that, we use the knowledge like one by one here, kinds of radical kinds of multiply. So here can be got a 5. And this one got square root 10, right? So this part can be combined together, all right? So when we say, let's see another example, something like this one. So this is a little bit same. We use the kinds of, so we use the both, when we do this one, right? When we do this one, we still also use the distribution progress, right? So you can got square root 3x times x and 5 So what happened here? Square root 3 times square root 3x, right? This is the part we distribute inside. So after that, this became 3x squared, right? 3x squared square root. What about this one? This one becomes inside, it became 9x, right? So this one can be changed into x, can take it outside. And this one 3, right? 9 became 3, became 15 square root x. Now, this is the version. So if you distribute inside it, you only got this one. So we do a little bit more simplified, so we can get this one. This is the final version. And we don't need to combine this anymore, this x and this square root x. So we just keep it as it is. That's good enough. All right, let's see next. All right, wait a minute, I missed something here. All right, okay, let's see. Did you guys understand what I'm talking? Everyone, can you guys something?
Yeah.
Okay, good. Okay, so when you do times, to multiply, we still use the same kinds of property of distributive inside. And that's the first step. After that, do further simplify, all right? All right, let's see some more examples. So right now we're talking about one term. You multiply two terms. Now what about two terms? This have two terms, right? Yeah, two terms. How they did this one? So we use the same as the radical, polynomial multiply, the kinds of procedure as well. All right. So we just use, you guys maybe still remember, use the FOIL, right? Kinds of distributed process. You can get square root first and second, and the third one is negative here, right? The third one is 7 times 10, 49. I'm sorry, negative here, 49, right? So you can got, this got a 5, this is got, this two term got middle two term got 0, and minus 49, right? So you can further simplify, got here. Is it interesting? So actually you can see these two terms is two terms difference and two terms, the sum of the two terms, difference of the two terms time together. Did you guys still remember this one? When we do the polynomial multiply, this one equals to a squared minus b squared, right? So if you guys notice these kinds of procedure, they are still the same. You can see this, the middle two parts became 0. Only became first term square and second term square, and then further simplify here. All right, let's see another one, examples. See the example here says, so see, this one is same as what we earlier learned in say a plus b squared, right? So it can be equals to first term square, and second term square, right? And plus 2 times a is, and b, right? So you can get here it becomes 7x, here is 4, so here is 4 square root 7x, right? So that's it. So this is the most simplified version already. So this one, the same thing, a plus b squared. Do you guys still remember this one? Nobody answer me?
Yeah.
Okay.
Yeah.
All right. So this is the same thing. When we do the multiply to the polynomial have two terms by two terms. Okay, let's move on another one. So it's just what I'm saying here, saying is so use the word earlier knowledge what we learned before. Only change is the x will right now became into a radical x, right? So what about when they are to divide? Right now, what do we say here? X. This one can be changed into, right? So that will be easy. Something like say square root. This one equal to 14 over 4 equal square root 7, right? When we say the inside, this one contains some variables. But it can be changed. It can be changed into, right? When they do the divide. So when they have these two terms to divide, so it can be changed into like this. So this further simplified, it became 4, and here it became 3. So it's 4. So this one can be taken 2x out, and the inside is only left is x, right? Because of this one is 2x, it comes from 4x squared, 4x squared times x, right? So here it became, right? So this one can be changed into here. Has to be easy, right? Only one radical divided one radical would be easy for this part. It's easy, further simplified. So you can use this kind of rule just like square root. All right, so this one I'm just rewrite here one more time. If their radical index is the same, we can put it inside, all right? But if their radical is different, what about when they are different? When they are different, all right, so let me give one question here, something like here. This is cubic root. How you do this one? So we needed to make this part the same, all right? How we make this part the same? This is 2 and this is 3. So we make it become 6. So here it became 6 means 2 cubic, right? So if you begin this, here it became 3 power. Is it correct? Everyone look at this one. So here, when we didn't write anything, here is 2, right? The index is 2, all right? So after you change this one, right now what you seeing here is this index right now is the same. So you right now can put it inside to change here. Here became 8, here became 9, all right? So in these cases can be combined like this way, all right? Okay, so let's move another one. If the divide, the top part right now is not only 1, it's actually have 2. What can we do in this case? Well, they have 2, all right? One they have 2. Something like, let me give one example. So, say 2 over 1. Excuse me. So, all right. So, Kongwei, what's your question? You raise your hand, Kongwei.
Oh, I did?
Yeah.
Oh.
And also, Senjie also raise hand. And Elena, did you?
Whoa, that was cool.
Anyone have question here or cannot hear me? What's the question? I cannot hear very well. No, I cannot hear anything. I hear from you guys. So have question, just unmute yourself and bring up the question, all right? If you don't understand, I can talk a little bit more. Okay, so let's see this one. See this example. See this example. So right now is the top one only 2, the bottom one have 2 terms. How we make this simplified? That's very big challenge here, right? So let's see one thing. How to make this radical denominator part radical disappear. All right. So let's be just one more thing. Do you guys still remember conjugate? Conjugate. Right now, what are we talking about here is a minus b times a plus b. This one equal a squared minus b squared, right? We take advantage of this one. All right. So what do we need to do here is we consider this one is the 2 terms, sum of 2 terms. And we want to do is add one layer conjugate. This relationship, these two relationship is called conjugate. The two terms difference and then two terms, sum of the two terms and difference of two terms. This relationship is called conjugate. So the same here, 1 minus square root 3, 1 plus square root 3. These two terms is called conjugate. All right. So after this one, so with both top and bottom side, times 1 minus square root 3. So you can see what's going on here, the bottom part. So this term so became 1 square minus square root 3 square, right? The top part became right here. So you can see what the bottom part changed. 1 minus 3, so it became negative 2, right? The top one is here. So it became negative 1. Here became negative 1. And negative 1 distributed inside became, right? All right, so this is the part we want to teach. This is very, very important part, what we want to learn today, okay? Let me give one more example here, put it at the top, to the left here. Let's see another example. All right, so let's see another example. So see how we, how to do this one. Okay, so top and bottom time as they are conjugate. What's the conjugate for the bottom part? Is actually is, right? So here it became square, right? The top, this one is the same, so it became square. So the bottom part it became this part square minus 4 square, square root 5 square minus 4 square, right? The top part right now became square. Square, we can do that is first term square and 4 square plus 2 times, right? We can got it here. So the bottom is 5 minus 16 became negative 11. All right, 5 minus 16 became negative 11. What's the top? Top here became 5 plus this 16 and this is 8, right? So you can got it here is negative 11. The top is 21 plus. All right. So here at least you can put a negative in here. Move the denominator part. Sorry, I don't know what's going on here. Yep. So here became this part. All right. Let's see another example here. Did everyone see here? Let me clear all. Let's see. Let's see this one. Can you guys take your notebook or do this one? How to rationalize this one? You can write on the whiteboard if you like. How to do this one? All right. So we can do the same time here. All right. The same thing. Find the conjugate. Here is 1 minus, right? So time 1 minus, right? So here became 1 minus x because of x is greater than 0, right? The square root x square became x, right? Top of y became 3, 1 minus square root x, all right? So that's good enough. That's good enough. We didn't further simplify here, all right? Okay, so since you guys do this one, let's move on a little bit equation, radical equation. Yeah, you can do a little bit further. That's great. I'd like you guys to write something on the whiteboard. No, you guys pay attention here. Very great, all right. So I will clear off you guys. So we know these kinds of simplification. So we move to our radical equation part. So we know x. All right, so with radical equation, we right now move down radical equation. All right. Okay, so like this one. Thank you. Thank you. Someone help me to put this out. So this one, so when we do this one, how we handle this one? Okay, the equation, it means at least have equations signal here, right? Earlier we talked about simplify, we do the radical addition, subtraction, multiply, and divide. And right now we move to equation. So equation means they at least have two parts. One part, right part is equation, right? We call it equation. So if we, firstly, we have these kinds of equation only have one content. I'm sorry, you have my kids just backside to close the door, make some bad noise. So, but it's here, in these kinds of equation, how we handle this one. So we need to get find out what the x, what's the solution, right? What's the solution of the x? What's the solution? So you can see if we do further, a little bit further, both sides -6. So you can get it here, right? We make it easier. But this one is not a good example, all right? I'm sorry, I need to change a little bit. This is not a good example. So you can see this one. Let's see here first. Any number square root can possibly equal -2? No, right? No number, because of the left part, just like square number, definitely is greater equal 0, but right now it's equal -2. So it means x have no solution. Let's see here. Let's see here. Because we right now need to make this square radical disappear, we need both sides square, right? So x equal 4. But when we check it here, square root 4, left part is equal 2, and right part is -2. Obviously, it's not equal. This means this answer, x equal 4, is not a correct answer, right? And we also earlier talked about here, say x squared root 2 is greater than 0, but the right part is -2. How is it possible? So it means definitely wrong. So no solution for these kinds of case example. But if you say, let's give right example. All right, so something like this one. So you can see here is became x. Yeah, so this answer is called, so someone put the right extras. So it means not real answer. This answer is additional, but it's not actually right? Extraneous. That's good. Very good. Thank you for putting this on. So what about this one? But both sides, this example here, square root x minus 6 equal 4. So you can get 10. So x equal 100, right? So put it, double check it. Square root 100 minus 6. The left part equal, this is 10, right? Minus 6 equal 4. And the right part is 4. So left equal right. Left equal right. Yep. So this is answer is correct, right? So it's easy to get this answer. All right. So this is the simplified version equation. We move a little bit complicated case. So if this kind of, see example here, x plus 3 minus x equal -3. Right now, the unknown number not at one place, have multi-place, have two places. So we try to move these kinds of non-square part in the one of the side and keep these kinds of square root in one side and keep the rest in the others at the other side. All right. So this one can be changed into x minus 3, right? So let's think about this one first. Say left part greater than 0, so and this part also need to be greater than 0. They can make sense, right? Everyone think, is it correct? So we move the radical part only left in the left side, the non-radical cancel term all to the right part. So we can think about here, say left part have radicals. So all the value should be make it greater than equal than 0. Is it correct? Anyone can answer me?
Yes.
Good.
Yeah.
That's nice. I like hear you guys some voice. I don't like it's too quiet. It looks like I'm the only talking person. Okay.
You think it would be like a ghost town?
Yes, you are right. So need someone make noise. So okay, see. So it means at least x greater than -3 for the left part equation. For the right part equation, say x need greater than 3, right? So combine these two. So it means x need greater than 3. That's the minimum. X at least is 3. Can make this one make sense. All right. All right. So take this apart first. Take this apart first. Take this. Think about it here a little bit. Just earlier thinking. All right. So that's how to get a square root right now. How to get this square root? We just need both sides. So since this part is greater than 0, right part greater than 0, they both square can be equal to each other, right? So both part square, they can equal to each other. If left part is a negative number, right part is a positive number, they square can equal to each other, but they are not make sense, right? So, all right, so we make sure both sides is greater than 0 and their square definitely is equal to each other. So what do we change into? So after that one, left part is left, is this one. Right part, we used the polynomial knowledge earlier. It became x squared minus 6x plus 9. All right, so this question becomes into polynomial factor. All right, we move the x all to the right, right? Minus 6 and plus 6. That part became 0. Do you guys think what our knowledge we want to learn? Polynomial factor, right? We just learned just a couple weeks ago. So it's minus 6, x minus 1 equal 0, right? So we use the knowledge of what we learned. So it means x, first x is equal 6, second solution is 1, all right? So we check it, which one makes sense. Right now we think, say, x need at least greater than 3, only 6 makes sense. This one is not greater than 3. So this is additional solution, but this is not correct. All right, let's double check here. Double check, let's check here. Let's check. So if we put a 6 here, 6 plus 3, right? Minus 6 equal, this is 9, right? This is 6 equal -3. So left equal right. It makes sense. But what about is the second question? Second question. Second solution, I'm sorry. The second solution here. If say 1 plus 3 minus 1. So here is 4, right? Minus 1 equal 2. And y equal -3. So it's not make sense. Y is -2. So it's not make sense, right? So that's why this x equal 1 is not the solution. Only this one is the solution. All right. Please don't write on the. Okay. All right. I clear yours. Okay. So it makes sense. All right. Let's do another one. Let's see another one. Please don't write later on the whiteboard. Thank you. Okay, so can you guys take your notebook, do this one? All right, right now I have 2 squares radical signal here. Have 2 radical square here. How can we do that?
The x, the -2 is not in the radical, right? Or is it?
Yeah, not inside.
So it's not, right?
Yeah, it's only stop here. They didn't go further. All right.
Okay. Okay.
Yep. No solutions. Who says no solutions? Who says no solutions? That's not right. Let's see here. We can firstly, we need to understand. This part, x minus 4 need greater than 0. So x at least is 4, all right? This is first. Second one, least one x greater than 0, right? So at mean combine these two, it means x at least 4. Let's put at least one first. All right, right here. All right, let's see next what do we need to do. So we could, if x is at least is 4, it means this part is greater than 0, 2, and this part is greater than 0, 2, right? So we can both part square first, right? So what do we change into? It's, so this one change here. What about right part? Right part change into first term, second term, right? First term and second term, right? And plus 2 times negative 2 times square root x plus here. All right. Let me rewrite the right part. So here it became x because x greater than 4, so it's minus 4 and plus 4. Yeah, thank you. All right. So x minus 4. All right. So let's see this one. So this equation. So this equation, what can be, so x can be taken out, x, right? So let's move all non-square root part in the left. Here became negative 8. Here is became, right? So both parts divide negative 4. So it's 2 square root x. So x equal 4. X equal 4. This one say x greater or equal 4. X equal 4. It makes sense, right? So let's double check it. 4 minus 4 square root equals 0, right? The left part equals 0. What about the right part? The right part equal square root 4 minus 2 also equals 0. So x equal 4 makes sense. This x equal 4 makes sense. So x equal 4, all right? He also met this situation. Someone send me a message. Okay. Oh no. Okay. Clear all drawings. All right, let's do another one. We have 4 more minutes. So let's see here. We know that one, this is the most complicated cases, but I need to give one more examples here. All right, let's run the homework part. Let's see. Uh-oh. Someone call me. Just pause a little bit.
Message from Comrade Sydney to GU Island. Sydney Plant Operations learned March 28th of an employee who has tested positive for COVID-19. This person was last in the plant March 17th. Any employees potentially having close contact?
Okay, all right. Sorry for that one. I just got a message from my company. So anyway, so let's move on here. Let's see, do one example here. All right, can you guys do this one? So here it means what? Firstly, we need to consider this equation. Have both sides have radicals, right? So inside should be greater than 0. X should be greater than 0. And after that, both sides can be do like this, right? So after that, what we can do, we can be changed. This one can be changed into x plus 6 equal what? Equal ax, right? So 3x equals 6. X equal 2. X equal 2. All right. So let's check it. Great. 16, both sides. Right side is here. So it makes sense, right? Okay. Let's see another examples. Next examples. Here say square root x equal x minus 2. So we need to know the x need greater than 0, right? On this part also greater than 0, greater or equal than 0. So x at least greater than 2. All right. So after that, what we need to do? Both part square both part square. Okay, all right, so what do you need to do? So will be changed into what? Left part equal x, right part equal x squared minus 4x plus 4, right? So move here, right? So x minus 4, we factor it equals 0. So x can be 4, x can be 1, right? So but now, right now we say x need at least greater than 2. So this one is correct. This one is not right answer. X minus x equal 1 is not, only 4. Let's double check it. If you put a 1 inside, the right part, it will be negative 1, right? It's not correct, right? So negative 1, yeah. Left part is 1, right part is negative 1. So it not make sense, right? So, all right. All right, let's move down. Let me touch it. Okay, this on. I keep that one right there for a little while. Let's see one more equations, all right? Before I give you code. All right, before we end, we give you code first. Homework code is, let me see. The code is, yeah, thank you for big one. 425725. Can you guys write down this one P first?
Yeah, we got that.
Oh, sorry. Let's see one more question. Let's see more examples, actually. I like more examples. Hey, don't do that. All right, see more examples. I want to give one more examples before I end today, okay? All right, so see these examples, equation. Equal x minus 5. Okay, so the same. We need to consider, make sure this part is greater than 0 and this part also greater than 0 because square root something is greater than 0. So x at least is 5. All right, keep this in mind first. Second, and then we make both sides square, right? So here you can got 2x plus 5, right part is x squared minus 10x plus 25. You can see we also use a lot of knowledge what we learned earlier, right? So what do we got here? So x minus, so we make this part get 0. Move all the data to the right. Okay, negative 2x and plus 20, right? So this one after factor can be 2 and negative 10, right? So x, one of them is 2, the other answer is 10, right? So we say x at least is 5. So only this answer is correct. This answer is wrong, right? Because if you put a 2 right here, the right part will be negative 3. All right. Okay. I think pretty much for today. Did you guys understand what are we talking?
Yes.
Yeah.
All right.
Yeah.
That's all for today. Make sure you guys copy the code and for the homework. Thank you again. See you next week. And Aiden and Jessica, please make up your homework. And the parts who didn't finish homework, please finish them. All right. Thank you. See you all later.
Thank you. Bye.
Thank you.
Have a wonderful weekend. Keep home safe and stay home safe. All right. Thank you.